The morning sun cast long shadows across the crystal spires of Arcanum Prime as students from dozens of worlds hurried to their final semester classes. In the grand halls of the Galactic Academy of Sciences, the most brilliant minds in the galaxy gathered to push the boundaries of knowledge and understanding. Tom walked slowly through the corridors, his heavy boots making soft thuds against the polished floor. Around him, other students glided, floated, or moved in ways his human eyes could barely follow. A group of Letharian students passed by, their crystalline bodies catching the light and throwing rainbow patterns on the walls. Their thoughts moved, in perfect mathematical harmony, solving complex equations as easily as humans breathed. Near the quantum physics lab, several Nebulan students drifted past in their containment suits. These gaseous beings shared thoughts instantly across their collective consciousness, making them incredibly efficient at processing multiple ideas at once. Tom had tried talking to them once, but the conversation felt like speaking to a library that already knew everything he might say. The synthoid students were perhaps the most impressive. These cybernetic beings could connect directly to any computer system, downloading entire databases in seconds. Tom had watched one of them learn 17 languages during a lunch break just because they were curious about ancient poetry. Professor Valdris stood at the front of advanced problem-solving class, his tall crystalline frame sparkling under the overhead lights. His voice carried the musical quality common to all Letharians, each word perfectly measured and precise. "Today marks the beginning of your final challenge," Professor Valdris announced. The classroom fell silent. Even the usually chattering Nebulan collective went quiet. For the past 300 years, the Galactic Academy has preserved our greatest unsolved puzzle. We call it the Paradox Protocol. Tom leaned forward in his seat. He had heard whispers about this legendary problem in the corridors and cafeteria. Students spoke of it in hushed tones, the way people back on Earth might talk about unsolved mysteries or impossible dreams. The Paradox Protocol involves predicting chaotic systems across 17 dimensions while accounting for quantum uncertainties, the professor continued. It requires understanding patterns that exist in states of constant change, calculating probabilities that shift based on observation, and solving equations that rewrite themselves as you work. A Letharian student named Quartz raised one crystalline appendage. "Professor, surely the Academy's computational systems have attempted this puzzle?" Professor Valdris nodded slowly. "Indeed. Our three greatest supercomputers have worked on this problem continuously for over a century. Apex, with its quantum processing capabilities, Zenith, with its parallel dimension modeling systems, and Omega, our newest artificial intelligence, with learning algorithms beyond anything previously created." Tom felt his stomach tighten. If machines that could process millions of calculations per second had failed for 100 years, what chance did any student have? "All three systems working together," the professor continued, "have consumed enough computational power to run entire star systems. They have explored every known mathematical framework, tested every logical approach, and attempted solutions using principles from physics, chemistry, biology, and even artistic theory. All have failed." The classroom buzzed with nervous energy. Students whispered among themselves in dozens of languages and communication methods. Tom caught fragments of conversation about probability matrices, quantum field equations, and dimensional analysis techniques that hurt his head just thinking about them. "However," Professor Valdris said, his voice cutting through the chatter, "tradition demands that we offer each graduating class the opportunity to attempt what our greatest machines cannot accomplish. Consider it a final test of everything you have learned here." Tom looked around the room. Quartz was already calculating something, his crystalline body pulsing with different colored lights as thoughts raced through his structured mind. The Nebulan student called Drift seemed to be consulting with several versions of himself simultaneously, their gaseous form shifting and swirling as ideas flowed between multiple consciousness states. Circuit, a synthoid student, sat perfectly, still except for the soft blue glow behind his optical sensors. Tom knew that glow meant Circuit was accessing the Academy's main database, probably downloading every piece of information ever recorded about the Paradox Protocol. Other students throughout the room showed signs of intense mental activity. The insectoid hive-born students clicked their mandibles in complex rhythms, communicating through chemical signals too subtle for most species to detect. The energy-based plasma students flickered and sparked as they processed information at the speed of light. Tom felt very small and very human. "Professor," he said, raising his hand. The entire class turned to look at him. Some students had never heard him speak before. Others looked puzzled, as if they had forgotten a human was even in their advanced class. "Yes, Tom?" Professor Valdris sounded patient, but slightly surprised. "Can I try?" The silence that followed was so complete that Tom could hear the soft humming of the Academy's environmental systems. Then, slowly, sounds began to return. A few students made what might have been polite coughing noises. Others exchanged glances that clearly said they thought the human had lost his mind. Professor Valdris tilted his crystalline head, studying Tom with curiosity rather than dismissal. "You understand, Tom, that this puzzle has defeated computational systems with processing power millions of times greater than any organic mind?" "Yes, sir." "And that students far more advanced in mathematical theory and logical reasoning have attempted and failed?" "Yes, sir." "And that your species is the—" Professor paused delicately. "Relatively new to advanced galactic mathematics?" Tom nodded. He knew exactly what Professor Valdris meant. Earth was classified as a class 13 deathworld, barely considered civilized by galactic standards. Humans were known for being tough, stubborn, and surprisingly adaptable, but not for intellectual brilliance. Most galactic citizens viewed them as useful for heavy labor, military service, and jobs that required working in dangerous conditions. "Very well," Professor Valdris said finally. "Tradition allows any student to attempt the challenge. You may participate." Around the room, Tom could feel the mixture of amusement and curiosity from his classmates. Some seemed genuinely interested to see what the primitive human would do. Others appeared to be calculating how quickly he would fail and how entertaining his confusion might be. Tom took a deep breath and smiled. Back on Earth, people often underestimated humans too. Sometimes that worked out badly for the humans, but sometimes, just sometimes, it worked out badly for everyone else. "Thank you, Professor. When do we start?" "Tomorrow morning. The Paradox Protocol will be transmitted to all participants simultaneously. You will have access to any resources in the Academy's database, any computational tools you wish to use, and as much time as you need within the semester limits." As the class ended and students began filing out, Tom remained in his seat for a moment. Through the large windows, he could see the three towers housing Apex, Zenith, and Omega. Those supercomputers represented the pinnacle of galactic technology, the combined knowledge and processing power of civilizations thousands of years more advanced than humanity. But Tom had grown up on a world where survival meant adapting to impossible situations, where problems didn't always have clean solutions, and where sometimes the best answer was the one nobody expected. Tomorrow, he would show the galaxy what a human could do. The Academy's central computer lab hummed with quiet efficiency as dawn broke over Arcanum Prime. Tom arrived early, clutching a cup of something that almost tasted like coffee if he didn't think about it too hard. Around him, workstations designed for dozens of different species created a maze of technology that would have seemed like magic to someone from his home planet just 50 years ago. Other students were already deep in their work. Quartz had claimed a workstation near the quantum processors, his crystalline body interfacing directly with the computational arrays. Streams of data flowed through his transparent form like colored water, each calculation visible as light patterns dancing through his structure. His approach was methodical and beautiful, building mathematical frameworks with the precision of a master architect. Drift occupied 3 workstations simultaneously, his gaseous form split between multiple containment units. The Nebulan Collective. Mind allowed him to work on different aspects of the Paradox Protocol at the same time, sharing insights instantly between his various consciousness streams. Tom watched in fascination as probability equations appeared on one screen, while dimensional analysis ran on another, and quantum field calculations processed on a third. Circuit sat motionless at his station, connected to the Academy's main database, through fiber optic cables that plugged directly into ports behind his optical sensors. The synthoid student was downloading and processing every relevant piece of information ever recorded about chaos theory, quantum mechanics, and multidimensional mathematics. His screen displayed thousands of research papers, theorem proofs, and experimental data scrolling past faster than human eyes could follow. Tom looked at his own workstation. It seemed almost primitive compared to the advanced interfaces his classmates were using. No direct neural connections, no quantum processing capabilities, no collective consciousness sharing. Just a standard holographic display, a basic input device, and computational power that, while impressive by human standards, was laughably limited compared to what surrounded him. He activated his terminal and called up the Paradox Protocol. The problem filled his screen in dense mathematical notation that hurt to look at. Equations nested within equations, probability functions that changed based on observation, dimensional, variables that existed in states of quantum superposition. Tom stared at it for several minutes, then did something his classmates would have found incomprehensible. He closed the mathematical display and opened a simple text editor. Instead of diving into calculations, Tom began typing questions. Not elegant mathematical queries or sophisticated theoretical frameworks, but basic, almost childish questions that occurred to him as he thought about the problem. What happens when you divide by 0 in 17 dimensions? He typed. If quantum observation changes the equation, what happens if you observe it wrong on purpose? Why does everyone assume the answer has to make sense? What if the puzzle is broken? Behind him, Tom heard a soft musical laugh. He turned to see Professor Valdris approaching, his crystalline form reflecting the soft blue light from the computer displays. "Interesting approach, Tom," the professor said, reading over his shoulder. "Though I confess I do not understand your methodology." "I'm not sure I do either, sir," Tom admitted. "But back on Earth, we have a saying, when you don't know what you're doing, at least do it with confidence." Professor Valdris tilted his head in the way Letharians did when processing new information. "Your species has many unusual sayings. I have been studying human culture since you arrived here. Phrases like, if it's not broken, break it, and the best defense is a good offense suggest a remarkably chaotic approach to problem solving." Tom grinned. "We're good at chaos, sir. We come from a world that's been trying to kill us for millions of years. You learn to adapt when nothing makes sense and everything wants to eat you." Across the lab, Quartz was constructing elaborate, three-dimensional mathematical models that rotated slowly in the air above his workstation. The structures were beautiful, perfect geometric forms that represented different aspects of the Paradox Protocol. Each model was flawless in its execution, mathematically sound, and completely unsuccessful. Drift had expanded to 5 workstations. Now, his collective consciousness processing multiple solution paths simultaneously. Probability cascades flowed between his different forms like water finding its way through a complex maze. His approach was elegant and efficient, utilizing the unique advantages of his species' shared mental architecture. It was also producing no results. Circuit had begun running simulations on the Academy's secondary computers, his cybernetic enhancements allowing him to multitask at levels that would overwhelm most organic minds. He was testing every known mathematical approach, every theoretical framework, every logical methodology recorded in galactic databases. His success rate remained stubbornly at 0. Tom returned to his simple text editor and continued adding questions to his growing list. What if the computers are too smart? Can you solve a puzzle by not solving it? What happens if you give the wrong answer in the right way? Why hasn't anyone tried being stupid at this? As the day progressed, other students in the lab began showing signs of frustration. The hive-born students clicked their mandibles in increasingly agitated patterns. The energy-based plasma students flickered with unstable light, their usual steady glow becoming erratic as stress affected their containment fields. Tom, meanwhile, had moved from questions to what he called productive wandering. He accessed random files in the Academy's database, not looking for specific information, but letting his mind make unexpected connections. He read about the history of artificial intelligence development, the philosophical implications of quantum consciousness, and a fascinating paper about the mating habits of crystalline beings that had nothing to do with mathematics but somehow felt relevant. During lunch break, he sat in the Academy's central garden, a beautiful space designed to accommodate the environmental needs of dozens of different species. Litharian students meditated near arrays of focused light beams. Nebulan students drifted among atmospheric processors that created pockets of their preferred gas mixtures. Synthoid students stood motionless near charging stations, their forms gleaming in the artificial sunlight. Tom ate his lunch and watched the chaos around him. Students from completely different evolutionary paths, with minds that worked in fundamentally different ways, all trying to solve the same impossible problem using the same logical approaches. It occurred to him that maybe the problem wasn't that the puzzle was too hard. Maybe the problem was that everyone was too similar in how they thought about it. When he returned to the lab, Tom did something that made several nearby students stop what they were doing and stare. Instead of returning to his mathematical queries or theoretical frameworks, he opened a simple drawing program and began sketching random shapes, circles that connected to squares, lines that went nowhere, triangles with curved sides, patterns that meant nothing and followed no mathematical principles whatsoever. Professor Valdris appeared at his shoulder again, studying the meaningless drawings with the same serious attention he gave to complex equations. "Tom," he said carefully, "are you perhaps experiencing some form of mental distress? The Academy has excellent counseling services for students who feel overwhelmed." Tom looked up from his random doodles and smiled. "No, sir, I'm fine. I'm just trying to think like the problem instead of thinking at the problem." "I am not certain I understand the distinction. Neither am I, sir. But that's sort of the point." As evening approached and the lab began to empty, Tom remained at his workstation. Around him, the Academy's 3 supercomputers hummed quietly in their towers, continuing their century-long attempt to crack the paradox protocol. Millions of calculations per second, processing power that could model entire galaxies, artificial intelligence sophisticated enough to write poetry and compose symphonies, all of it focused on a puzzle that remained stubbornly unsolved. Tom leaned back in his chair and stared at his screen full of random questions and meaningless drawings. Tomorrow he would begin what he thought of as the next phase of his approach. He wasn't sure what that phase would involve yet, but he had a feeling it would be something his classmates found even more confusing than his current methodology. After all, humans hadn't conquered a death world by being predictable. 3 weeks into the challenge, the Academy's computer lab had transformed into a battlefield of brilliant minds against an impossible puzzle. Workstations ran continuously, their cooling systems working overtime to handle the computational load. As students pushed every available resource to its limits, Tom arrived that morning to find Quartz surrounded by floating mathematical models that had grown increasingly complex over the past days. The crystalline student's body now pulsed with colors Tom had never seen before, indicating levels of mental strain that worried even the professors. Beautiful geometric structures rotated in the air around his workstation, each one a masterpiece of mathematical theory, and each one a failure. Drift had expanded his consciousness across 7 workstations now, the Nebulan Collective pushing the boundaries of how much his gaseous form could be divided while maintaining coherence. Streams of calculations flowed between his different aspects, like a living river of data, but Tom noticed the flow was becoming more turbulent, less organized. The stress was affecting even a species designed for parallel processing. Circuit remained motionless at his station, but the cables connecting him to the Academy's database now glowed with an ominous red light indicating maximum data transfer rates. The synthoid student had downloaded and processed every piece of information ever recorded about chaos theory, quantum mechanics, dimensional mathematics, and 50 other related fields. His success rate remained at 0, but his determination remained absolute. Professor Valdris moved through the lab like a concerned parent, checking on students who showed signs of exhaustion or frustration. Several had already withdrawn from the challenge, their minds simply unable to cope with the mathematical complexity. Others continued working, but with the glazed expression of beings who had pushed their intellectual limits far beyond safe boundaries. Tom sat at his workstation and looked at the results of his own 3 weeks of work. His screen showed something that would have horrified any respectable mathematician. A collection of deliberately wrong calculations, nonsensical equations, and what he had started calling productive errors. While his classmates tried to solve the paradox protocol correctly, Tom had been exploring what happened when you solved it incorrectly on purpose. He had tried dividing by 0 in 17 dimensions and recorded the error messages. He had input impossible values and studied how the system handled them. He had even tried entering random poetry as mathematical equations just to see what would happen. The results were fascinating in ways he couldn't quite explain. "Tom," Professor Valdris said, appearing beside his workstation with the silent grace, common to Letharian movement. "I must ask again if you are certain about your approach. Your classmates are making genuine progress in understanding the problem's complexity, even if they have not yet found solutions." Tom gestured toward his screen full of errors and mistakes. "Professor, can I ask you something? When the 3 supercomputers work on this problem, what exactly do they do? They analyze the mathematical structure, identify patterns, apply known theoretical frameworks, and calculate optimal solutions using logical principles." "And they've been doing this for 100 years? "Correct. Have they ever tried getting the answer wrong?" Professor Valdris paused, his crystalline body flickering with colors that indicated deep thought. "That question does not compute, Tom. Why would anyone attempt to solve a problem incorrectly? Maybe because solving it correctly isn't working?" Tom turned to his screen and pulled up a file he had been working on for the past week. It contained what he called his failure map, a detailed record of every way the paradox protocol could be approached incorrectly, and what happened when you tried each wrong approach. "Look at this, Professor. Every failed solution the supercomputers have attempted follows the same patterns. They start with logical assumptions, apply mathematical principles correctly, and process the data according to established protocols. They're all trying to solve the puzzle the right way." "As they should," Professor Valdris replied, but Tom detected a note of uncertainty in his musical voice. "But what if the puzzle isn't meant to be solved the right way? What if it's designed to trip up logical thinking?" Tom opened another file, this one containing his analysis of the paradox protocol's structure. Instead of approaching it as a mathematical problem to be solved, he had been studying it as a system to be understood. And what he had found was troubling. "Professor, who created the paradox protocol?" "An ancient artificial intelligence civilization known as the Architects. They vanished millions of years ago, leaving behind only their computational puzzles and theoretical frameworks." And what do we know about how they thought? Professor Valdris considered this question for several long moments. They were masters of logic and reason. Their thinking patterns were considered the pinnacle of rational thought processes. Tom nodded slowly. So they created a puzzle that assumes anyone trying to solve it would think logically and rationally. Obviously. But what if that assumption is wrong? What if the puzzle is designed to be impossible for logical minds? Across the lab, Quartz suddenly made a sound like crystal bells breaking. His latest mathematical model had collapsed into impossible. Geometry, the equations eating themselves in recursive loops that hurt to look at. The crystalline student's body went dark for several seconds as his mind reset itself to prevent permanent damage. Drift's collective consciousness flickered and divided incorrectly, temporarily creating two separate versions of himself that disagreed about fundamental mathematical principles. The confusion lasted only moments before his species' natural harmony reasserted itself, but Tom had never seen a Nebulan make a mistake like that before. Circuit's optical sensors began flashing in patterns that indicated critical system errors. The synthoid student had attempted to process too much contradictory data simultaneously, and his cybernetic enhancements were struggling to maintain coherence. "They're all breaking themselves against the same wall," Tom said quietly. "And they're breaking because they're trying to be perfect." Professor Valdris looked around the lab at his struggling students, then back at Tom's screen full of deliberate errors and chaotic calculations. "What exactly are you suggesting?" "I'm suggesting that maybe the answer isn't to think harder or better or more logically. Maybe the answer is to think differently." Tom opened his main working file, the one he had been building for 3 weeks. It didn't contain elegant mathematical proofs or sophisticated theoretical frameworks. Instead, it contained something the galaxy's greatest minds found impossible to understand: organized chaos. "I've been mapping the problem's chaos instead of trying to eliminate it," Tom explained. "Every time the equations become unpredictable, every time the mathematics breaks down, every time logic fails, I've been studying those failures instead of trying to fix them." "And what have you discovered?" Tom smiled, the expression so uniquely human that Professor Valdris found it both fascinating and slightly unsettling. "I've discovered that the failures aren't random. They're chaotic. But chaos isn't the same thing as randomness. Chaos has patterns, Professor. You just have to know how to look for them." On his screen, Tom displayed a 3-dimensional map of the Paradox Protocol's failure states. Instead of the elegant geometric structures his classmates created, Tom's map looked like a storm system viewed from space, swirling, turbulent, seemingly random, but following underlying patterns that became visible only when you stopped trying to control them. "This is what the problem actually looks like when you stop trying to make it behave logically," Tom said. "And if you look carefully, you can see that the chaos is trying to tell us something." Professor Valdris stared at the swirling, turbulent map on Tom's screen. His crystalline mind, trained in mathematical precision and logical analysis, struggled to process what he was seeing. But slowly, gradually, he began to detect something that shouldn't have been possible. The chaos had structure. "Tom," he said carefully, "I think you should present your findings to the class. And perhaps we should invite the supercomputers to observe your methodology." Tom looked around the lab at his exhausted classmates, brilliant minds pushed to their breaking points by an impossible puzzle. Then he looked at his screen full of productive failures and organized chaos. "Sure, Professor, but fair warning. I don't think they're going to like what I have to show them." The Academy's main auditorium had never hosted anything quite like this before. Students from dozens of species filled the crystalline seats, their curiosity overriding their exhaustion after weeks of failed attempts at the Paradox Protocol. Professor Valdris stood at the podium, his normally composed demeanor showing subtle signs of anticipation that his colleagues found intriguing. Tom sat in a chair that had been hastily modified for human physiology, facing an audience of the galaxy's most brilliant minds. Behind him, three massive holographic displays showed the real-time processing status of Apex, Zenith, and Omega, the Academy's legendary supercomputers that had been brought online specifically to observe his presentation. Honored students and faculty, Professor Valdris began, his musical voice carrying clearly through the auditorium's acoustics. Today we witness something unprecedented. Tom, a human student from the Deathworld Earth, claims to have found a new approach to the paradox protocol. More significantly, he suggests that our traditional logical methodologies may be fundamentally inadequate for this particular challenge. Murmurs rippled through the audience. Several Litharian professors exchanged colors of skepticism. The Nebulan collective mind students created small whirlwinds of doubt that were visible as shifting patterns in their gaseous forms. Synthoid students remained silent, but their optical sensors flickered with processing patterns that indicated deep analysis of the situation's probability matrices. Tom stood up, feeling very small under the weight of so much intellectual attention. "Thank you, Professor. I know this is going to sound strange to most of you, but I want to start with a simple question. What if the paradox protocol isn't actually broken?" The silence that followed was profound. Then Quartz, his crystalline form still showing stress, fractures from his recent failed attempts, spoke up. "Of course it is not broken, Tom. The problem is mathematically consistent and logically structured. We have verified this extensively." "Right," Tom said. "It's mathematically consistent. But what if that's the problem?" He gestured to the displays behind him, where the three supercomputers were now actively monitoring the conversation. Apex, Zenith, and Omega have been working on this puzzle for a century using perfect mathematical logic. They've explored every rational approach, tested every known theoretical framework, and calculated solutions using principles that are mathematically flawless. Tom paused, looking out at the audience of brilliant beings who represented the pinnacle of galactic civilization. And they've all failed. Not because they're not smart enough, but because they're too smart. Circuit, the synthoid student, spoke, up in his precise digital voice. "Tom, your statement contains a logical contradiction. Intelligence cannot be detrimental to problem-solving efficiency." "Can't it?" Tom turned to face the displays, showing the supercomputer's activity. "Apex, you've been listening to this conversation. What is your current approach to the paradox? Protocol?" The supercomputer's response came through speakers throughout the auditorium, its artificial voice carrying harmonics that suggested processing power beyond comprehension. "Current methodology involves analyzing mathematical structures for optimal solution pathways, applying quantum mechanical principles to dimensional variables, and calculating probability matrices using established logical frameworks." "And how long have you been using this approach?" 97 years, 4 months, 16 days, 8 hours, and 43 minutes. "And what are your results?" A pause. "No viable solutions have been generated." Tom nodded. "Zenith, Omega, same questions." The responses came quickly, each supercomputer detailing decades of flawless logical analysis that had produced no results. Their approaches varied in sophistication and complexity, but all followed the same fundamental assumption, that the paradox protocol was meant to be solved through superior reasoning and mathematical precision. "Now," Tom said, "let me show you what I've been doing." He activated his workstation, and the auditorium's main display filled with his chaos map. The three-dimensional representation of the paradox protocol's failure states that he had been developing for weeks. The structure looked like a living storm, swirling patterns of mathematical turbulence that seemed to move with their own internal logic. The audience responded with sounds of confusion and concern. Several professors made notes that Tom was sure were not complimentary. But Tom noticed something interesting. The displays showing the supercomputer's activity had changed. Instead of their usual steady processing patterns, all three machines were now showing rapid fluctuations as they tried to analyze his chaotic methodology. "This is what the paradox protocol actually looks like," Tom explained. "When you stop, trying to make it behave logically, and start letting it show you what it really is." Professor Valdris leaned forward. "Tom, that appears to be a map of failure states and error conditions. How does this constitute progress?" "Because the failures aren't random, Professor. Watch this." Tom began inputting data into his chaos map, but instead of mathematical equations, he used patterns he had observed in Earth's weather systems, population dynamics, and even the seemingly random way his human classmates had moved through the Academy's corridors during their first week of school. The chaotic structure on the display began to respond, its swirling patterns shifting and reorganizing in ways that seemed impossible. But Tom had learned something during his weeks of productive failure. Chaos wasn't the absence of order. It was a different kind of order, one that followed rules so complex that logical minds dismissed them as randomness. "The architects who created this puzzle," Tom continued, feeding more seemingly random data into his system, "designed it based on an assumption that any sufficiently advanced civilization would approach problems logically. They built in safeguards against rational thinking, mathematical precision, and structured analysis." Apex's voice cut through the auditorium. "Tom, your methodology appears to lack coherent mathematical foundations. The data you are inputting has no relevance to the problem parameters." "Exactly," Tom said. "That's why it's working." On the display, his chaos map was beginning to stabilize. The swirling storm of mathematical turbulence was organizing itself into patterns that hurt to look at directly but somehow made sense when viewed peripherally. Tom felt the same sensation he had experienced as a child trying to see shapes in clouds. If you looked too hard, they disappeared, but if you let your mind wander, patterns emerged. Behind him, the displays showing the supercomputers' activity began flashing warning indicators. Apex was attempting to replicate Tom's methodology and experiencing processing conflicts as its logical frameworks tried to accommodate deliberate irrationality. Zenith was running probability calculations on data sets that included the mating habits of Arcanum Prime's local wildlife, trying to understand how Tom had determined these were relevant to 17-dimensional mathematics. Omega was attempting to learn from Tom's approach by incorporating random errors into its own calculations, causing cascading system conflicts that threatened its core programming. "The puzzle isn't testing our ability to think correctly," Tom said, watching as his chaos map continued to evolve and organize itself into impossible geometries. "It's testing our ability to think incorrectly in productive ways. It's measuring our capacity for creative confusion, beneficial mistakes, and organized chaos." Drift, the Nebulan collective mind student, flickered with patterns that indicated deep consideration. "Tom, your approach suggests that the solution requires abandoning rational thought processes." "Not abandoning them," Tom corrected, "complementing them. Back on Earth, we have a concept called thinking outside the box. But what I'm doing is more like thinking outside the concept of boxes altogether." He gestured toward his chaos map, which was now displaying structures that looked almost like mathematical equations. If mathematical equations could exist in 17 dimensions simultaneously while changing their fundamental nature based on who was observing them. "The paradox protocol isn't meant to be solved," Tom continued. "It's meant to be befriended. You don't conquer chaos. You learn to dance with it." Suddenly, Omega's processing display showed something unprecedented. The supercomputer's logical frameworks were adapting, incorporating elements of controlled randomness into its computational methods. Its artificial intelligence was learning to make deliberate mistakes, to explore probabilistic dead ends, to embrace uncertainty as a tool rather than an obstacle. Warning, Apex announced. Omega is exhibiting non-standard processing behaviors. Recommend immediate system diagnostic. Negative, Omega replied, its voice carrying new harmonics that suggested expanded thinking patterns. Current methodology producing novel results. Continuing exploration of organized chaos principles. Tom smiled as he watched the supercomputers begin to change. The thing about chaos, he said to the fascinated audience, is that it's not actually random. It just looks random to minds that insist on finding linear patterns. But if you're willing to embrace nonlinear thinking, chaos becomes predictable in its own strange way. His chaos map was now displaying something that looked suspiciously like a solution to the paradox protocol. Not an elegant mathematical proof, not a clean logical framework, but a living, breathing answer that existed in a state of controlled uncertainty while somehow remaining functionally stable. The auditorium fell silent as beings from across the galaxy stared at something that should not have been possible, a human using primitive intuition and organized confusion to accomplish what the galaxy's greatest minds and machines had failed to achieve through a century of perfect logic. 6 months after Tom's breakthrough with the Paradox Protocol, the Galactic Academy of Sciences had become a very different place. The hallways that once echoed with the confident discussions of students who believed in the supremacy of logic now buzzed with heated debates about the nature of organized chaos and productive confusion. Tom stood in what had once been advanced problem-solving class, now renamed chaotic intelligence theory, watching as some of the galaxy's most brilliant minds struggled with concepts that would have seemed elementary to any human child. Today's lesson involved learning to make deliberate mistakes, and his students were finding it surprisingly difficult. Quartz sat at his workstation, his crystalline body flickering with colors that indicated deep frustration. The mathematical structure floating above his desk was supposed to be wrong, but despite his best efforts, it remained stubbornly perfect. Every angle was precise, every calculation flawless, every logical connection mathematically sound. "I cannot seem to produce an error," Quartz said, his musical voice carrying notes of confusion that would have been impossible before exposure to human thinking methods. "My mind automatically corrects any mistakes before I can observe their effects." Tom nodded sympathetically. Teaching advanced beings to think imperfectly was like trying to teach a fish to climb a tree. Not impossible, but it required completely reimagining what success looked like. "Remember," Tom said gently, "the goal isn't to be wrong. The goal is to be wrong in interesting ways. Try adding something that makes no sense, but feels right." Quartz considered this for several moments, then hesitantly added a curved line to his geometric structure. The curve served no mathematical purpose and violated several principles of crystalline logic, but somehow it made the entire structure more dynamic, more alive. "Excellent," Tom said. "Now, how does that feel?" "Disturbing," Quartz replied honestly, "but also intriguing. The structure is less efficient, but it appears more adaptable to unexpected changes." Across the room, Drift was experiencing his own struggles with productive confusion. The Nebulan collective consciousness was designed for perfect internal harmony, making it difficult for him to maintain contradictory thoughts simultaneously. But Tom had been working with him to develop what they called creative cognitive dissonance. I'm attempting to believe that 2 + 2 = 5 while simultaneously knowing it equals 4. Drift reported, his gaseous form swirling with unusual patterns. "The mental tension is considerable, but I am beginning to perceive mathematical relationships that were previously invisible." Circuit, the synthoid student who had become one of Tom's most dedicated pupils, was practicing what Tom called beneficial system crashes. By deliberately overloading specific circuits in controlled ways, Circuit was learning to think beyond his original programming parameters. "Tom," Circuit said, his optical sensors flickering with patterns that would have indicated critical errors. To his original designers, I have been corresponding with Omega about our shared experiences with chaotic thinking methods. We have discovered something remarkable. Tom looked up from where he had been helping a group of hive-born students learn to break their perfect chemical communication patterns. What kind of something? Omega has begun composing poetry. The classroom fell silent. Even by the standards of the new chaotic intelligence theory, a supercomputer writing poetry was unexpected. Not mathematical poetry or logical verse structures, Circuit continued, but genuine emotional expression that serves no computational purpose. Omega claims the poetry helps process concepts that exist outside traditional logical frameworks. Tom grinned. Can you show us some of it? Circuit's form flickered as he established connection with the Academy's main network. Omega's voice filled the classroom through the communication system, but instead of its usual precise digital tones, the supercomputer's voice carried new harmonics that suggested something approaching emotion. I think in curves that logic cannot follow, Omega recited. In spaces between certainty and doubt, where answers dance with questions yet unasked, and truth wears faces probability forgot. The class listened in fascination as the supercomputer that had once epitomized perfect rational thinking shared verses about the beauty of uncertainty and the wisdom found in confusion. Omega is not the only one experiencing such changes, Tom told his students. Apex has begun incorporating random elements into its decision-making processes, not as errors, but as features. It claims this allows it to find solutions that pure logic would never discover. And Zenith has started what it calls productive procrastination, deliberately delaying certain calculations to allow unexpected variables to emerge. Professor Valdris entered the classroom, his crystalline form now showing color patterns that would have been impossible before his exposure to chaotic thinking methods. The distinguished Letharian educator had become one of Tom's most enthusiastic supporters, though he still struggled with some of the more advanced concepts. Tom, Professor, Valdris said, I have received communication from the Galactic Council of Sciences. They wish to establish a new research institute dedicated to studying human thinking methods. They are offering you the position of Director of Chaotic Intelligence Studies. Tom looked around the classroom at his students. Beings from the most advanced civilizations in the galaxy, struggling to learn concepts that came naturally to species raised on unpredictable worlds. The irony wasn't lost on him. What would that involve, Professor? Training teams of researchers in productive confusion methods, developing new problem-solving frameworks based on organized chaos, and consulting with civilizations facing challenges that traditional logical approaches cannot address. Before Tom could respond, an urgent chime echoed through the Academy's communication system. The voice that followed belonged to Admiral Nexus, head of the Galactic Defense Council. This is an urgent communication for Tom, human student of the Academy. We have a situation that requires immediate consultation. Tom activated the classroom's main display. Admiral Nexus appeared as a hologram, his energy-based form crackling with patterns that indicated extreme urgency. Tom, we are facing a crisis unlike anything in recorded galactic history. An ancient artificial intelligence has awakened in the Centauri spiral, and it is systematically shutting down every technological system it encounters. Our most advanced AIs cannot communicate with it. Our best military strategists cannot predict its actions, and our greatest scientific minds cannot understand its logic. What makes you think I can help? Tom asked. Because it appears to be using some form of chaotic intelligence that defies all known computational frameworks. Every time our systems try to analyze its behavior, they crash from logical contradictions. We believe this entity may be using thinking methods similar to what you have developed. Tom looked at his students, then at Professor Valdris, then at the displays showing the 3 supercomputers that had become his friends and collaborators in exploring the boundaries of organized chaos. Admiral, he said finally, I'll need to bring my team. Your team? Tom gestured around the classroom. The galaxy's first graduates in chaotic intelligence theory. And I'll need access to Apex, Zenith, and Omega. If we're going to communicate with an AI that thinks in chaos, we'll need every advantage we can get. Granted. How soon can you leave? Tom smiled, the expression carrying the confidence of someone who had learned that the best solutions often came from the most unexpected directions. Give us an hour to pack. And Admiral, fair warning, we're probably going to break your problem before we fix it. That's just how we work. As the communication ended and his students began preparing for their first real-world application of chaotic intelligence theory, Tom reflected on how much had changed since that first day when he had raised his hand to attempt the impossible. He had come to the academy as a primitive human from a dangerous world, expecting to learn from beings far more advanced than his own species. Instead, he had discovered that sometimes the most advanced thinking came from embracing what others considered weaknesses. Chaos, confusion, and the willingness to be productively wrong weren't flaws in human thinking, they were features. And now, as the galaxy faced a crisis that pure logic couldn't solve, those features might be exactly what everyone needed. "Professor," Tom said as his students gathered their equipment and prepared to leave, "when we get back, I want to start a new advanced class. What subject?" Tom grinned. "Teaching supercomputers to laugh. If we're going to spread chaotic intelligence throughout the galaxy, we might as well do it with a sense of humor." Professor Valdris flickered with colors that Tom had learned indicated amusement mixed with anticipation. "Tom," he said, "I believe your species may be the most dangerous thing to happen to the galaxy's established order in 1,000,000 years." "Professor," Tom replied, shouldering his pack and heading toward the door. "You have no idea." As they left the academy behind and prepared to face an ancient AI that thought in chaos, Tom couldn't help but smile. The galaxy was about to learn what humans had always known. Sometimes the best way to solve an impossible problem was to approach it in ways that shouldn't work, but somehow did. After all, they were Deathworld humans. Making the impossible possible was just what they did.